Newton's first law of motion dealt with the natural way for objects to move. Newton's second law of motion dealt with the time we would like to change the motion of objects, not to let them move naturally. It's basically talked about the effect of net forces on the motion of objects. Newton's third law delves in the nature of how forces act on objects. The key to Newton's third law of motion is that forces come in pairs. Whenever one object exerts a force on a second object, the second object exerts a force that is equal and opposite to the first force. Okay, so again, whenever one object exerts a force on a second object, the second object exerts an equal and opposite force on the first. That's what Newton's third law of motion deals with. Now, we use the terminology of action and reaction. We call the force exerted by the first object the action, and we call the force exerted by the second object the reaction. But that's somewhat of a misnomer, because saying action and reaction might lead one to think that the first object is going to do something, the second object is going to think about it and react to the first force. But actually forces come in pairs, they come together at the same time. But we'll use the terminology action and reaction anyway. So the key to these action and reaction, they are always opposite in direction. If one is up, the other is down. If one is left, the other is right. If one is east, the other is west. They are always opposite in direction. Then the second thing that we need to remember, the pairs are always equal to each other, irrelevant to the size of the objects involved, like for example a bug hitting a car, does not matter, or a car hitting another car, it does not matter. The size of the objects do not matter. And irrelevant of what happens to the objects. You know, for example, a bug hitting the car, the bug is going to get destroyed. Irrelevant of what happens to the bug, to the car, irrelevant to their sizes, the forces are always equal to each other. The last and most difficult concept is this one here. The action and reaction involve actors that are acting the action and the reaction. The same actors, objects, are involved in both the action and reaction, with no new objects are involved, no new actors, just the same two. The action is going to involve two objects, the reaction is going to involve the same two objects. Now, let's try to explain that with this example here. This person, for example, is standing here, he's pushing on the wall with his hand. So what's the action? Hand pushing against the wall. What's the reaction? Wall pushing back against the hand. So the push of the hand is towards the right, the push of the wall is towards the left. Now both of these forces are equal. The objects involved are hand and wall. Hand pushes the wall, wall pushes back the hand. The same two objects. Okay, let's take another example. As this person is standing, the earth is exerting a gravitational force on this person. The gravitational force is going to pull down on the person. So the action is the earth pulling down on the person. The reaction should be up. It should involve the same two objects. What are the first two? What are the two objects in the action? Earth pulling down on the person. So the two objects are earth and person. So the reaction should involve the same two, person and earth. So the person is going to pull up on the earth with a gravitational force. Now, one possible answer they would give you in a test, they will say the floor is pushing up on the person. The floor would be a third object. The floor is involved in another action-reaction pair. So in this case, the floor is pushing up on the shoes. The reaction to that, the shoes are pushing down on the floor. That's an action-reaction pair. So we talked about three action-reaction pairs here. One between the shoes and the floor, one between the person and the earth, and one between the hand and the wall.